Hi guys, my name is Aditya Santosh Nalla. Um, I'm from first year CSC Data Science A section, and my roll number is 701. Today my tech talk topic is from the subject BW Basic Electrical Engineering. In this in this subject, my topic is non-standard electrical networks and resurrection of Kirchhoff's laws. So let us discuss the introduction to the Kirchhoff's laws. Since Kirchhoff's laws are consist of two types. One is Kirchhoff's current law and Kirchhoff's voltage law. The first one, the Kirchhoff's current law, it tells us about the it tells us the about it is also known as the junction law or nodal rule. It is simply we can say it as sum of the currents entering into the node is equals to sum of the currents flowing out of the node. Here the node represents the junction or the particular point in which the particular currents flows through it. So in this diagram you can see here. Here is a node and resistance voltmeter, like that voltage, and the currents are flowing here, I2, I3, and flowing out of from the road, I1, I4. Since we can say it as the sum of the currents entering into the junction is equal to sum of the current leaving from the junction. On other case, we can say it as the summation of all the currents entering into the junction is always equals to 0, and it involves some sign conventions, such as if uh, since the if any currents entering into the junction is entering into the junction, will consider it as plus positive sign, and currents moving out of the junction is known as we consider it as a minus sign. As you can see here, I2, I3 are moving into the junctions, and I1 and I4 moves out of the junctions. So we consider I2 plus I3 is equals to I1 plus I4. Is the representation for this, or we can see it as I2 plus I3 minus I1 minus I4 in this way. So similarly for the Kirchhoff's voltage law, and this is this law is also called as the mesh rule or the voltage law. Hmm. It represents the voltage symbol, and it is directed the sum of the potential differences around any closed loop is equals to 0, or sum of the loops is always equals to 0 having voltages around V1 plus V2 plus V3 plus V4. In this diagram you can see here, or or another definition for that is the sum of the voltages rises is equals to the sum of the voltage drops, like that we can say, in other words. So these are some of the introduction for the Kirchhoff's law, as we studied in the previous lower classes. Let us come into the topic, some elements of the non-standard analysis. So let us explain some of the elements to the non-standard analysis, which enough to provide an understanding to the non-standard theory we introduce below. This section presents bare minimum of ideas and more detailed instructions of non-standard analysis. It can be found of number of sources. It is related to the current theory, and mainly related to the electrical ones, and it consists of the two types of approaches. One is axiomatic approach and constructive approach. Axiomatic approach, it is based on the symbolic logic, and it is the method which is used by the Robinson in his seminal works. As a result, in earlier explorations on his kind, but did not provide much intuitions as a nature. This is mainly the axiomatic approach, which is mainly related to the logic, and Robinson. He is a scientist who worked from this axiomatic approach, and but it does not provide any intuitions, and does not give any detailed information about this approach. And second type of approach is constructive approach. It is mainly probably more accessibility to the customed to the mathematical analysis rather than mathematical logic, in particular to circuit theorists. It is this idea is reworked for interstitials and to a certain equivalence classes on the sequences. The real numbers approximate zero in a such a way, which is called, which some sequences which are partitioned into equivalence classes is called as hyperreal number, and they include not only infinitesimals but also close to any real numbers as well as the large numbers. So let n be equals to any 1 2 3 4 so on, like that, any positive natural numbers, and let an be is set is equals to an of n, for that such n, n belongs to capital N for any sequence of the real numbers, and two sequences an and bn is known as the equivalent. So and they are same on the large enough, and it is subset to capital N, which is the sequence of the real number. And the conditions for each we use cap for m is subset to n, either m of n is equals to 0 or m of n is equals to 1. These are some of the conditions for that, for the electrical circuits and non-standard analysis. And if m of capital N is equals to 1, if m is finite subset to n, if m is finitely additive inverse, then m1 and m2 will become the disjoint sets, and m of m1 union m2 is equals to m of m1 plus m of m2. So in so there are two types of non-standard networks. One is infinite non-standard electrical networks, and infinite and non-standard electrical networks. So our object for the non-standard analysis is applied to the electrical networks. In other words, we wish to lift the theory of such networks from the real into hyperreal number, and for the sake of specificity, for the nodal analysis we are always aware of the nodal analysis. If any circuit is given, uh, there are many points or junctions, we'll see is known as the nodes, and kind of a network, and it is finite connected network to p plus 1 nodes. Here the p here the p represents the number of nodes branches which are present. With each, let us consider returns or an independent current source along with the HJ or a parallel combination of GH and HJ. It is a Norton's form of branch, and it varies from 1 to Q, which is known as the standard network. So with superscript of T, T denotes the transposing of the matrix, as we studied in the maths, and the column vectors we use V1, VQ and whole transpose. This represents the vector branch voltages of currents, and choose a ground node in G and index remaining nodes by k is equals to 1 to p. Let akj be the p cross q be the matrix, since where if 1 or minus 1 then nkj, and these are some of the examples for that matrix related to that. And and another one is non-standard one ports and their hyperreal representations. So as we studied in the previous sections about non-standard network in with the hyperreal parameters, which has a voltage design but also parameters, and it represents the electrical circuits. And the hyperreal parameters of the non-standard one port are the images of parameters in the real circuit. Non-standard one port, it is described is it is the formula for the non-standard ones. I is equals to GV minus H, where capital G represents the conductance, I represents current, and V represents voltage, and H are the hyperreal images having reals of G and H. This is the formula for use, and an infinite parallel circuit to the conductances as you see here. Let us assume for a non-standard one port, I is equals to GV, as I represents current, G represents voltages, current input and the particulars on the particular G is equals to G1, G2, G3 so on, be any hyperreal. A1 is equals to G1, AK is equals to GK minus 1, and for K represents from 2 to 3, 4. Like this way represent like that, and infinite series circuit of the resistances, and it is the kind of circuit we wish for one port consistent, while whose infinity extremity is one of the terminals. R1 is R is equals to R1 comma R2 comma R3 so on in that, and x1 is equals to R1, since in the previous slide we use AK is equals to AK minus R, and similarly we use X here for the infinite series. We use here Thevenin's branches, the only V is equals to IR minus E, and it is more generally any non-standard Thevenin's branch with the representations. Yes. So, and finally we conclude that the separate analysis for the individuals on ports followed by non-standard analysis in the single analysis, after having portioned n into one ports, each of the form is internally infinite of the type discussed in the subjection, have a standard analysis of the network, and n is opening by the shortening on the accordance with the type of one ports of the branches around. So thank you.